Section 10.2.4 is titled Tangents, and it will answer the question, what is the relationship? Be sure you read the math notes on page 21 first. Today we're going to look at question 88, which says, consider all the ways a circle and a line can intersect. Can you visualize a line and a circle that intersect at exactly one point? What about a line that intersects a circle twice? On your paper, draw a diagram for each of the situations below, if possible. If it is not possible, explain why. So first they want us to draw a line and a circle that do not intersect. So here's our circle, here's our line. They're not going to intersect. B says draw a line and a circle that intersect at exactly one point. When this happens, the line is called a tangent. Highlight that word. So they're intersecting at this one point right there. C says draw a line and a circle that intersect at exactly 2 points. A line that intersects a circle at 2 points is called a secant. So it's intersecting right here and right here. And then D says draw a line and a circle that intersect 3 times. This is not possible because unless that line is squiggly, it's not going to happen. And question 89, we're going to go ahead and turn over to the top of page 19. Question 90 says, Ventura begins to think about perpendicular line segments in a circle. He wonders, if a radius is perpendicular to a line at a point on the circle, will that line always be a tangent line, or could it be a secant line? His team decides to explore his question. Thigh says, let's assume the line perpendicular to the radius is a secant. Label the points where the secant intersects the circle A and B. Since Ventura's question assumes that the line is perpendicular to a radius, assume that line AB is perpendicular to CA at A. So angle CAB is a right angle. Ventura adds, I think triangle CAB is isosceles. Do you agree? And explain how you know. So CA is going to be isosceles because CA is congruent to CB. They're both radii, and all radii in a circle have the same length. So that makes that an isosceles. C says, Sandra chimes in with, then angle CBA must be a right angle too. Ventura quickly adds, but that's impossible. What do you think? Discuss this with your team and give reasons to support your conclusion. So they are both correct. However, this creates a triangle that has 2 right angles, which makes it an impossible triangle, because that would make your triangle more than 180 degrees. Part D says explain to Ventura what this contradiction reveals about the line perpendicular to the radius of a circle at a point on the circle. This means the original assumption that the line is a secant is false. It must be tangent. Okay. Question 91. On a map, the coordinates of town A, B, and C are at A is at -3,3, B is at 5,7, and C is at 6,0. City planners have decided to connect the towns with a circular freeway. Graph a map of the towns at right. Once the freeway is built, segment AB, BC, and AC will be chords of the circle. Use the information to locate the center. So label all your points A, B, and C, and then your center should be at 2, 3. Draw triangle ABC and use a compass to draw the circle connecting all 3 towns on your graph paper. The circle that you drew circumscribes triangle ABC because triangle ABC is inscribed inside the circle. What is the radius of the circular freeway? What is the special name of the center of the circle? It's called the circumcenter, and the radius is going to be 5 units long. If we count from the center, it's 1, 2, 3, 4, 5 units this way. The city planners also intend to locate a new restaurant at the point that is an equal distance from all three towns. Where on the map should the restaurant be located? And justify your conclusion. It should be at the center because it is equidistant from all the points on the circle. We're going to skip page 20 and then make sure that you read all the math notes box on page 21.